Hi, it's Renata here. If it's your first time here, welcome to my channel, The Quanti Girl, where we are going to talk about some topics in quantitative finance, in pure and applied mathematics, in Python programming, and sometimes about music, because I'm a PhD in mathematics and a financial quantitative analyst that is also a violinist, and I'm here to share with you some of my knowledge. Today we are going to implement in Python the concept of stopping times in Markov chains, so just keep watching the video and we are going to talk about it. Before we start coding, let's talk a little about what is stopping time in Markov chains, and for this, first of all, let's talk about what are Markov chains. Markov chains are mathematical models that describe a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. Now, let's apply this concept to stopping times. Stopping time refers to the moment when a process reaches a particular state for the first time and remains there indefinitely. In finance, for example, this could represent hitting a certain price level or reaching a specific market condition. In order to illustrate the concept, let's consider an example here. So, imagine you are an investor monitoring the stock market. You are interested in knowing when a stock price reaches $100 for the first time. Using Markov chains, we can model this scenario by defining states where the stock price is below $100 or equal or above to $100. As the stock price fluctuates, the Markov chain calculates the probability of transitioning from one state to another. So eventually we reach the state where the stock price hits $100 for the first time, representing our stopping time event. So in quantitative finance, understanding stop times allows us to make more informed decisions, such as when to buy or sell assets based on specific market conditions. Markov chains provide a powerful framework for modeling these situations. So let's start coding. The first thing that you need to do is to import the libraries that we are going to use. So let's import the libraries we are going to use. I think this is the only library that we are going to use today, NumPy. So if we need more libraries later, we import them later. Okay, so to compute the stopping time, the first step is to define a Markov chain transition matrix. So let's define a Markov chain. Okay, let's store our transition matrix into an object. Let's call it transition matrix. So let's define our transition matrix, and for this we are going to use the NumPy library. So let's put some numbers here. You can change it if you want. So we need two arrays. So the first array is one array for the transition of one state for another. Okay, we are going to simplify things here. Let's assuming that we only can have two possible states, state 0 and state 1, for example. So the first array that we defined here are the transition probabilities from the first state, state 0, and now let's define the second array that represents the transition probabilities from the other state, state 1. Again, I'm defining some probabilities here, but you can change if you want. So let's comment here. This is the transition probabilities from the first state, state 0, and here are the transition probabilities from state 1. Okay, so we have our transition matrix here. Let's run it. Okay, yeah, I think it's okay now. Let's check it. Okay, I think it's okay now. Let's move on. And now let's define initial state probabilities. So let's define initial state probabilities. Let's keep it on a new object. Maybe do, for example, initial state probabilities. And again, let's call NumPy library. Let's assume that we start in state 0, for example. You could start on state 1. That's only the two possibilities that we have here, because we are assuming only two possible states in our Markov chain. So as I said, let's suppose we are starting at state 0. Let's comment just to document it. Okay, now let's move on, and we need to define a stopping time event. So let's write a function to do that. Okay, let's comment just to keep clear what we are doing here. So now we are going to define a stopping time event, and we are going to use a function to do that. So let's define a function called stopping time event, and the argument of the function is the state of the Markov chain. We just need to return the state in which the event occurs. Let's suppose here that the event occurs when the state 1 happens. In a more general Markov chain, let's say with the 3 states or more, whatever the number of states, you need to define what is the event to be reached by the Markov chain. Okay, so we are defining here that state 1 is the event we are looking for. So let's comment it just to keep clear what is happening here. Okay, so now we hear our transition matrix. We have our initial state probabilities, and we have the stopping time event. So now let's move on and simulate stopping time using a Markov chain that, and this Markov chain is the things that we defined here. So now we are going to simulate stopping time using our Markov chain. So let's define a function. Let's call it simulate stopping time. And the arguments are the transition matrix. A transition matrix, you can define a different one from this. Uh, the initial state probabilities, and okay, that's all the arguments. So let's initialize a variable to count the number of steps. Let's initialize it as 0. Let's simulate states. Again, we are going to use NumPy here. Okay. We need the initial state probability. Okay, so now we continue to iterate, counting the number of steps until we reach the event we are looking for, that in this case we define it as the state 1. So we need a loop here. So while we don't reach the stopping time event of state 1, we continue the loop. So while we don't reach the condition, we continue to iterate. So we continue to update the state variable and the number of steps. Okay, so while we don't reach the state 1, that is the event that we defined here, we need to update the number of steps, adding 1 unit. So the loop is that, and what we need to return in this function is the number of steps, that is the number of steps to reach the event that in our case here is the state 1. Okay, so now let's move on and simulate multiple scenarios to see the function working, to find the stopping time. So now we're going to simulate scenarios. So we need to define a number of simulations. Let's put it as 1000 or whatever number of simulations you want. And we need what we are looking for is to calculate the stopping times for each of these simulations. So let's store it into a variable called stop times. And now we are going to call the simulate stopping time function to compute the stopping time. And we need to calculate the stop time for each simulation. So we need to iterate here in the number of simulations. Okay, I think it's okay. Let's run it. Okay, so here we have the stopping time calculated for each one of the 1000 simulations. And now let's see what is the average stopping time of all the simulations. It's very simple. We just need to take the average of all the stopping times that we calculated here. So let's stock it, keep it on a variable called average stopping time, for example, or whatever name you want. And it's just the average. You can use the main function from the NumPy library to compute the average of all the 1000 stopping times. Let's print this average stop time. And it's the variable average stopping time. Okay, let's run it. So the average stopping time of all these stopping times is 10.229, and that's all. This code defines a simple Markov chain with two states below threshold, that we are assuming state 0 here, and above or at threshold, state 1 in our case. It then simulates multiple scenarios of transitioning between states until the stopping time event occurs, reaching the threshold, the state 1 here, and finally it calculates the average stopping time across all the simulations. So that's all for today. Hope you like the video. Don't forget to hit the like button because it helps me a lot. And also don't forget to subscribe to the channel so you can know when I upload the next videos. So see you guys in the next video. Bye!